All right, thanks. Thank you for choosing to join my talk here today. My name is Marit van Dijk, and I'm here to talk to you about keeping your dependencies in check. So usually I start with a question to make sure we're on the same page, and I ask who uses open source software in their projects at work or at home, and all of the hands go up. So just to check, is there anyone who doesn't use open source software? Don't be shy. Okay, so all of us. So good, we're starting on the right page. So open source is great because, you know, it allows you to use a bunch of functionality without having to write it yourself. So you can use your application frameworks, testing frameworks, all kinds of tools without having to write them yourselves. So we can focus on delivering business value for the company that we work for. But there are downsides. For the dependencies that we declare, they also use dependencies. So instead of just the dependencies that we declare, we are pulling in transitive dependencies, who might even have more transitive dependencies. And, you know, they can lead to all kinds of trouble. They'll make your binaries bigger because you're pulling in a bunch of stuff. If you're really lucky or unlucky, there will be clashes between different transitive dependencies that you have to resolve. And of course, any of those dependencies that you declare or the ones that they pull in can contain vulnerabilities. If you're a Java developer, who is a Java developer? Okay, for the rest of you, bear with us. So if you're a Java developer, you'll remember what happened in December of 2021. Even the people nodding up front, yes. So, thank you, Liz. What happened was people were getting ready for the holidays, and Log4Shell was disclosed. And in fact, literally at my previous job, I had a coworker who is a Log4j maintainer. He was literally planning to go on holiday when this vulnerability was disclosed, and instead worked 22-hour days to fix it. So this is your cue to thank an open source maintainer today. So what that meant for the rest of us was urgently updating all of our applications. In some cases, even twice, because after the first vulnerability was fixed, it turned out there were several others that also needed to be fixed. And I was working at an online retail platform at the time where teams were responsible for several microservices, so it meant updating literally several applications, and then again after the second CVEs were fixed. Which was nice, because in March of the next year, we got to do it again when Spring4Shell dropped. But the upside is we had just gotten a lot of practice urgently deploying everything, some even on a Friday, as recommended by Charity at Honeycomb. So, you know, we got our practice in urgently deploying our applications. But to be fair, I prefer my software development to be a little more boring than that. So we know that there are pros and cons to using external dependencies. So first I want to look at what to look for when what to look for when selecting dependencies and why that's important. I've seen two extremes of dealing with this. One is literally like, okay, we're not using any external dependencies, or, you know, as little as we can possibly get away with, and you end up writing a lot of stuff yourself, which is great because then you have full control of it, but you're going to slow down your software development and delivering your business value. On the other hand, you don't want to be like this and just, you know, import any dependency. I have a problem, I'll go look on Stack Overflow or ask ChatGPT for the solution. It suggests to import this dependency and all of my problems will magically go away. Let's just do that and not think about it. Also not great. So let's start by considering whether we need the dependencies that we're using, preferably before we start using it. But if you're in a situation where you currently have a bunch of dependencies, maybe take the time occasionally to reevaluate whether you still want them, whether these are still the ones that you want, and whether you still need them to solve a particular problem. So what are some of the things that you want to think about? First, you want to think about, is this library or framework a good fit for the problem that I have? Both in terms of, is it the right solution for this problem? But also in terms of, is the relative size of this framework or library relative to the size of my problem? Or am I using, there's a Dutch expression, using a cannon to shoot a mosquito? You know, if it's too much for your small problem, maybe there's a better solution out there. You want to consider whether this dependency is well maintained. And that means, are there frequent releases? Are bugs fixed fairly quickly? Are there active maintainers? Is there more than one active maintainer? Because there's an XKCD for everyone, some of you recognized it right away. There are lots of projects that are maintained by one person who is doing a thankless job, not getting any appreciation for it. And what happens if that person, for whatever reason, can no longer maintain this library? A term that's sometimes used here is the bus factor. How many people can get hit by a bus before this project goes unmaintained? And I really, really don't like this term, because I don't want to be thinking about people getting hit by buses. So I've heard an alternative term, which I like a lot more, which is called the lottery factor. How many people can win the lottery and never have to code again if they don't want to? You know, some of us are idiots and prefer to do this even for free. How many people can win the lottery and no longer have to write code before this library goes unmaintained? You might want to consider the community around a particular project. Are they friendly? Are they welcoming? Are they nice to people who start using it for the first time and ask a bunch of newbie questions? Are they kind to people who report issues or create pull requests? I was looking at a project recently that I was thinking of maybe looking into contributing to. I looked at some issues and they were arguing. I'm like, okay, maybe not this project. So consider whether you like using it. We all have personal preferences. We like using certain tools and we dislike using other tools. So, you know, we have hopefully some flexibility into making our jobs more enjoyable if you can select the ones that you like. And think about the impact that a particular dependency will have on your code base. Some dependencies are relatively small. I'm thinking string utils, for example, is fairly small. You'll use it only in very specific places. If you ever decide you want to remove it, because, for example, actual example, you're moving from Java to Kotlin and you're going to use extension functions instead, you can easily remove it. Other libraries, for example, if you're using Lombok or a reactor, will infect your entire code base and they will be everywhere and removing it will be harder. Much like having dandelions in your garden. Ask me how I know. And finally, if you decide that you do want to use a particular dependency, make sure that you use a version that doesn't have any known vulnerabilities. Jamie Coleman over at Sonatype shared this website with me. They have an overview of the number of people who are still downloading that particular version of Log4j with the severe vulnerability. And this is a screenshot from a few weeks ago. 23% of people are still downloading that version. I looked to update the slide today, and the numbers are still the exact same. So either they're no longer updating this website or nothing has changed and people are not replacing this with a newer version. So where do we find this information? One place to look is Maven Central. Or nowadays, Sonatype will redirect you to central.sonatype.com because they've been running Maven Central for a very long time. And here you can look for packages in the JVM ecosystem, and you can find information about specific dependencies, how to import it to your project. This is what it used to look like. This is what it looks like now. So you can find how to import it to your project. You can find additional information, some metadata, what license it uses. They give a safety rating here, and you can go to the OSS index to see whether a particular version has known vulnerabilities. So the latest version of Jackson Databind does not have known vulnerabilities, but older versions do. Of course, Jackson Databind is a serialization, deserialization library, for those that are not familiar, which is notorious for having interesting security problems. So they tend to have known vulnerabilities that are then fixed, etc. Not saying you shouldn't use it, just something to be aware of. And definitely not meaning to diss on Jackson Databind, because we did use that at my previous company. Another place to look for this information is the package search website by JetBrains, which has similar information. So you can find the latest versions. You can find links to tags on Stack Overflow if you want to see whether there are questions and how helpful people are in answering those, the type of license that it uses, how to import it to your package, and also a list of versions if you want to see how often new versions are released. Or, of course, you can go directly to the code. You can find a lot of information on GitHub or wherever the project is hosted. Of course, you can look at the actual code if that's something that you're interested in. But also on GitHub, you can look at insights, which will give you an idea of the heartbeat of the project, how active is the project. You can see number of pull requests, merged by how many people, etc. And you can have a look at contributors, which will track contributions by contributor over time. So you can see that Jackson Databind, for example, is maintained pretty much by only one person, which is kind of scary. So that is, slightly other rant, but, if more people could get involved in open source, that would be great. So overall, we know that maintaining our dependencies is important. But most developers would much rather be doing something else, right? So we're going to look at some of the tools that we can use, and I'm going to start with tools that you probably already have, and then move on to other tools that you can use if you're not already. So we can use our build tools to get an overview of the dependencies we currently have. So if you're using Maven, you can ask for a dependency tree, which will tell you these are your direct dependencies, and then with interesting lines and squiggles, you can figure out on the command line what you're pulling in as transitive dependencies. You can also ask Maven, are there updates available for the dependencies that I'm currently using? And this is what I used to do several years ago before we had other tools available. If I was working on a particular repository for microservice, I would do the thing that I was supposed to be doing, like adding a feature, fixing a bug, and then afterwards do a little bit of scouting to see, are there minor updates that I can do, small things that I can fix. I would always be fixing the typos because apparently I'm the only one who sees them. Small things like that to make the project slightly better. Of course, you can't see if one of these versions is a release candidate. You can't see that here. You have to go to Maven Central or Central Sonatype. You can also ask Maven to analyze your dependencies, where it will show you used undeclared dependencies to give you more insight, or unused declared dependencies that you might want to remove. Of course, in this example project, don't remove JUnit, add tests. But this is a demo project that I built without any tests. This is not running in production, don't worry. It was just a demo project. It's also hopelessly outdated, but it's a lovely example from my graveyard of GitHub projects to show you how to deal with outdated dependencies. Gradle, of course, has similar commands. You can ask for the dependency tree. It doesn't have built-in things to ask for updates, but you can add plugins like the BenMains version one to ask for, hey Gradle, are there any updates to my dependencies? And if you want to analyze your dependencies and see, for example, whether you have unused dependencies, also you need an additional plugin, which you can then add, and then you can run commands as well to see which are unused, and it can actually also fix them for you. So that's kind of nice. Of course, IntelliJ has a bunch of features on dealing with your dependencies. Obviously, you can see them in your build file. So is this, can you read this up top? Yeah, okay. So you can look in your pom.xml or your build Gradle to see which dependencies are declared. This is something that I like to do when I'm joining a new project or a new team, just to get a feel for what type of things do they use. And if there are things that are new, then I look into, hey, what is this? What does it do? And learn something new. Of course, we can find all of the jars that are pulled in under the external libraries, but this doesn't really give you a feel for what the tree looks like and what's pulling in what. So for that, we can check the either the Maven or the Gradle tool window, where we can expand them to see which declared dependency is pulling in which transitive dependencies. And here we can also analyze our dependencies. So we can search for specific dependencies in the list. We can select only a specific scope if we want to. And we can look for any conflicts that we might need to resolve. We can also manage the versions. So we can add and remove dependencies from right inside the IDE. Of course, we can do that in our build file, but we can also get an overview of which dependencies do we have, which scope and version do we have. We can add new ones if we're looking for something new. It will also tell us if there are versions that we can upgrade, and we can upgrade them individually or all at the same time. But if we don't want to go to the latest version, we can also pick a different version. And here we can see the information that we can also see in the package search website. We can see it right inside our IDE. So we don't have to leave our IDE to get this information. We can get it right here, so we don't get distracted by the internet and start reading Twitter or whatever your favorite social site is. So that's one thing that we can do. Also, you might notice that some dependencies have, I don't know if you can see the little squigglies really clearly, but some of them have squigglies, meaning, hey, there's a newer version of this available. And the ones that are highlighted in yellow are highlighted because they actually have known vulnerabilities, as you can see in the pop-up here, or if you do Alt-Enter, which is the way of IntelliJ IDEA or IntelliJ-based IDEs of fixing things, you can see that there's a new version available. Now, if you do the hover and it works, come on. Anyway, the hover that we just saw that doesn't want to show itself now, it will list the CVEs that are in there. You can click the link to go to the website of Checkmarks, which is the company that we're partnering with to provide this information. But of course, we can also see this information right inside our IDE. By opening the vulnerable dependencies window, we can see which vulnerabilities were found. Again, old project, not running in production, don't worry. We can see the severity of the vulnerabilities that were found. We can click them to get information on which CVEs are in there and what the problem is, and we can fix it right inside our IDE. So we just covered a bunch of slides. So if you're interested in learning more about this, I did some videos on our IntelliJ IDEA YouTube channel. So please like and subscribe, thank you. Okay. So pros and cons. The tools that we've just seen, we can check the dependencies while we're working on the project, which is nice if we want to do a little bit of extra scouting and make it better while we're there. But the downside is we need to check out each individual project, see if there are updates that we can do, fix those, etc. And of course, we need to apply those updates and then verify that everything still works. Now, if you have a bunch of microservices that you're responsible for, that gets tiresome quickly. So here's where another set of tools comes in handy, which is software composition analysis. I'm not going to look into all of the different tools that you can use, because as developers, we often don't have a lot of influence over which tool your company uses. But I hope that your company uses some kind of software composition analysis tool, and if not, maybe ask the security department what's up with that and are they looking into it, etc. Because these tools can scan all of your repositories and containers for known vulnerabilities and then create an overview. So at the company I was working for before, we had a dashboard for each of the teams that would show these are your repositories, these are the known vulnerabilities, their severity, etc. And you know whether you have work to do because you have to only look in one place. So you don't have to, the upside is you no longer have to check out each repository, but you do have to go to the dashboard to see if you have work to do, and then again, of course, apply and verify those updates. The next set of tools that you can use are bots that can do automatic PRs for you. I'll focus on the ones that work with Java. If you're using a different language and you're not on the JVM, there are additional options, but I think all of these also work for other languages. The first one is Dependabot. Dependabot is GitHub native. They acquired it in 2000 something, I forget. And it offers several features. One is alerts, so it will give you an alert if you're using vulnerable versions but without doing anything. The second is security updates, so if you're using a dependency that has known vulnerabilities, it will create a PR to update that dependency for you. And the last one is version updates, so if there's a new version, not necessarily because of security reasons, you can update to that. Because it's GitHub native, you can enable it from the settings. If you go to Code Security and Analysis, you can enable either the alerts and or the security updates. And you also can have a dependency graph, which will show you all of the information. So it used to be that it highlighted in yellow that you had known vulnerabilities. It looks like it no longer does that, but I've been doing this talk for a year and turning it off and on and off and on again, and none of the bots seem to really like that. So if you enable this on your repositories, it might look slightly different, but the general idea will be the same. So it will give you information on which dependencies it wants to update for you. You can expand the thing to say, to give you a little bit more information. They used to give quite some information in the PRs that they created, but also it seems that they no longer do that. So they're just saying, okay, I want to bump this version, but not necessarily providing you with information on why. And if you want to do the version updates as well, so there is a new version of this library, not necessarily for security reasons, you need to add a YAML file. Also, your regular reminder that YAML sounds like jammer in Dutch, which is the word for too bad or unfortunate. So, but anyway, we use it for configuration. It has white space that has meaning, which is all sorts of fun. And you need to specify the package manager and the location of your build file, the schedule with which you want it to run, and you have some additional optional configuration, like what is the maximum number of PRs that you want in order to not get overwhelmed. Do you want it to automatically rebase or not, etc. It's GitHub native, but you can also configure it to run on GitLab if that's what you're using. But you have other options. The next option is Renovate, which is what we used at my previous employer. They also offer security updates and version updates, and they give you a project dashboard, which shows you what you need to update for your particular project. It's not GitHub native, but there is a GitHub app. I tried them all on GitHub because that was the easiest way for me to try them. You need to add it to your account. Renovate, by default, offers you the option to select only one repository to run it on. So if you've never tried any of these bots and you want to try it, you can try it on just one repository, which is nice. It will create the configuration file for you in a PR, and once that's merged, it will start doing its thing. You can, as I said, select all your repositories to run it on or specific repositories only. And Renovate, I think, is the only one that allows you to do that as you're setting it up. The configuration file is created for you. Yay, less YAML. You can set the scheduling. You can also set the number of maximum number of PRs, but also the number of concurrent branches, because of course you have more than just incoming updates. You also have other stuff that you're working on. It does have a rule-based auto-merge, so for things that you know you want to update anyway without looking at it, you can set up a rule to do that. And overall, it has more options and is more fine-grained than Dependabot. The PRs provide more information, so they'll tell you this is what we want to update and why. They give you, this screenshot is old, don't worry. They'll give you the age of the package, the adoption rate among Renovate users, the percentage of passing tests, and the confidence level that they determined, where neutral means that either they don't have enough information or they can't determine on the information that they have. They'll give you a dashboard of everything that you need to update in your project. Again, old project, everything needs to be updated. And there's a dashboard of all of the jobs that have been run. If you need to go debugging those, hopefully not. They support a bunch of platforms, including GitHub, GitLab, and more. The last option is Snyk open source, which also offers security updates and version updates, but they have some additional features that can be really nice. One is that they can test for vulnerabilities on incoming PRs, which the other two don't. So that's nice, because if someone tries to add a vulnerable dependency in between, your weekly run, you can catch that on the incoming PR. And they can also test for vulnerabilities in your source code, which I won't look into because I'm comparing bots right now. And they create dashboards for you that are slightly better looking than the Renovate ones. You can enable Snyk via their website. You can choose how to integrate, set permissions. So here you have the option between public and private or public repos, but you don't have the option between one or all repositories. And you can configure which features you want to use. They have the option, or they used to have the option, on whether you want to only update your repositories for known vulnerabilities that you already have, and or also for newly disclosed vulnerabilities. So if you want to first or separately remove your backlog of old known vulnerabilities separately from new incoming vulnerabilities, you can do that. You need to authorize them, and their PRs also provide you with a bunch of information of this is the update that we want to do, this is why we want to do it, severity, etc. And by default, Snyk will bundle related updates. So if you have a framework that has several separate dependencies that need to be updated, they will bundle that into one PR. Snyk does that by default. Renovate can be configured to do that. Of course, they have the PR check on incoming PRs, checking them for vulnerabilities that the other two don't. And as I said, the dashboard looks slightly nicer than the Renovate dashboard. Their configuration options are a little bit more limited than Renovate, but you can set the frequency, you can enable or disable for either new vulnerabilities or known vulnerabilities, and you can enable or disable for specific projects. So if you want to only run it on one project, you can, but you have to manually disable it for all of the other ones. They also support a bunch of platforms, including GitHub, Bitbucket, GitLab. So for Java, you have these three options. If you're using different languages, these options also support different languages, but I didn't look into which languages because I use mainly Java and Kotlin. And for other languages, there are also other bots available. People ask, okay, which one is the best one for me? Kind of depends. If you're on GitHub, Dependabot is easy to use. If you're worried about incoming New vulnerabilities, maybe go with Snyk so it can check your PRs. But overall, using one of these, any one of these, is better than not using them. So pros and cons of bots. They're fairly easy and straightforward to add to your repositories. Of course, it depends on the platform that you're using and which bot you select. But I spent a lot of time, or I spent not a lot of time, I spent some time adding them to the repositories of the last team that I was in, and it was way less work to just click through a bunch of settings for each repository than it is to manually check for incoming updates. It will create automatic PRs for you on your repository, meaning that you don't have to monitor either doing a Maven command or a Gradle command, or monitor a dashboard to see whether there are known vulnerabilities. The bot will create the PRs for you. A downside is that can create a lot of noise, especially if you have already have some known vulnerabilities in your repository that you need to you have a backlog that you need to get rid of. It can start spamming you with a lot of PRs. That's why you can set a maximum number. But you will have to deal with these PRs. You will have to see, does my project still build if I do this update? Of course, if it's green, that doesn't mean that there aren't any side effects, so you might still want to do an additional tests depending on how confident you are in your test suite. If it's red, you know that there is extra work to do. There might be tests that are failing. It might be that your code no longer compiles, so at least you know, okay, there's an update that I might want to do, but I know that there's more work. But it cannot make changes to your code. So this is where the last category of tools comes in. There are migration tools that can help you migrate your code as well as just the version of the dependency that you're using. And we'll look at a few. Obviously, I have to tell you that IntelliJ IDEA has such an option. There is a refactor. There's a migration refactoring, which by default offers a few migrations that you might find useful. One is from Java EE to Jakarta EE. One is from JUnit 4 to 5, which I hope everyone is already on JUnit 5, right? Okay, good. And one is for Java FX. And you can create your own migration. And what it will do is it will replace old package names with new package names in your code, so you don't have to go manually search through your code base to replace it. There are videos on our YouTube channel also if you want to, if you still need to do these migrations. The next tool I want to discuss is Error-Prone, which is, I think, only for Java. It's a static analysis tool to catch common programming mistakes. So not necessarily intended as a version migration tool, but it's intended to replace certain patterns in your code with a different pattern. You can use it running, you can run it using Maven, Gradle, or plugins for your IDE. So what it can do is it can find bug patterns in your code. It can alert on those, just to let you know, hey, you're doing something you probably don't want to. But it can also fix it, and it includes a tool called Refaster, which can refactor your code using before and after templates. And they have a bunch of bug patterns that they've already identified with possible fixes that you can apply to your code base, but you can also define your own. And I know that at Picnic in the Netherlands, they have used this tool also to upgrade from, for example, Java 8 to Java 11, using certain patterns that they had identified. Sander Mak, a developer from Picnic, has done talks on this, and Rick Ossendrijver is doing those talks as well. So if you want to know more about Error-Prone and how they're using it, I'd recommend you check those out. They, in fact, have cloned the repository to include some of their own patterns, and they've open sourced that, so if you want to contribute to that, you can. And they have a very cute little ghosty logo that goes with that. The last tool I want to tell you about is OpenRewrite. OpenRewrite is explicitly intended for migration. So it's a source code refactoring tool for framework and API migrations, vulnerability patches, and static code analysis fixes. So if your Sonar cube is lighting up, there are recipes in OpenRewrite that can help you fix those findings. It has Java, Kotlin, and Groovy support, because I'm on the JVM. You can run it with Maven or Gradle, or without a build tool, and they're working on early support as well for Python, TypeScript, and working on other languages as well. So if you're using something other than JVM languages, do have a look at what they're offering. And they're still working on expanding those offerings. So they have a bunch of recipes that are already created, either by OpenRewrite or by other open source projects. So they have common static analysis, issue remediation, migrations from one version of a framework to a higher version of a framework, but also migrations between libraries. So if you want to move, for example, at the bottom you see Hamcrest to Assert J, OpenRewrite can do that for you. Recipe catalogs per topic. So as you can see, there might be some stuff for Python in there. Definitely for Kotlin and Java, there's some stuff in there. And you can author your own recipes. So if you have specific needs within your company, or you want to migrate from one version of an internal library to another version, you can write your own recipes to migrate your code. My friend Tim de Beek, also from the Netherlands, works for Modern, the company behind OpenRewrite, and he has a talk called Major Migrations Made Easy, where he explains everything that you can do with OpenRewrite. So if you're interested to learn more about that, I'd recommend catching or finding that talk. We've been doing both of our talks for the past year, often at the same conference. So usually I could be like, go see Tim, but he's not here right now, but go see Tim online. So in conclusion, start by evaluating which dependencies you want to use, or occasionally re-evaluate the ones that you have. Automate the checks and updates as much as you can, and stay safe. Also, don't forget to rate this talk. Thank you.